Preparation of solutions of ascorbic acid, potassium citrate, sodium hydroxide, and silver nitrate with a molar concentration of 0.1 was carried out, with potassium citrate as a reducing agent to carry out our chemical synthesis of silver nanoparticles.
3 beakers were labeled. 4 milliliters of the ascorbic acid solution and 4 milliliters of the citrate solution were added to each. Subsequently, the pH was adjusted to each mixture with the values of 10.9, 11.5, and 12 with the 0.1 molar sodium hydroxide solution. Observing in detail the exact value and then comparing it with the color of the nanoparticles obtained. Finally, 1.0 milliliters of the silver nitrate solution was added to each glass, and the solutions were left to stand. After a minute, the color began to appear as can be seen in the image.
Oven drying. The drying of the solutions was carried out in an oven for 12 hours. In this case, we were able to observe that the solution with a pH of 12 showed better parasites based on what was reported in the literature. Nanoparticle suspension. In order to analyze in UV-vis spectrometry, the nanoparticles were suspended in water with the help of a sonicator, and 2 solutions were made, 1 milligram in 100 milliliters and 1 microgram in 100 milliliters.
The solutions were subjected to UV-vis analysis in the laboratory of the Laboratory 103 of the Faculty of Chemical Sciences. Next, the capacity of the nanoparticles to inhibit the growth of microorganisms was evaluated by seeding in nutrient agar with Escherichia coli and Staphylococcus aureus bacteria.
Prior to seeding, the culture medium was prepared and sterilized with an autoclave.
Preparation of culture medium. Once the medium was sterilized, each of the pretty boxes was filled, where the antimicrobial capacity of the silver nanoparticles against Escherichia coli and Staphylococcus aureus bacteria will be evaluated. The first box was the target. Half of the box had S. aureus and the other half E. coli. The second box was divided in half. In the center was placed a circle of paper moistened with a solution of nanoparticles 1 milligram in 100 milliliters. Half of the box had E. coli and the other half had S. aureus. For the third box was the same case, but with a solution of
The results obtained from UV-vis spectrometry were not as expected. An absorbance band was found in the region of 250 nanometres to 300 nanometres, which indicates the absence of silver nanoparticles, compared to what is reported in the literature.
The rest of the boxes were divided into 5 sections. Section 0 corresponded to silver nitrate, Section 1 to nanoparticles obtained with pH 11 in 1 mg solution in 100 milliliters, Section 2 to nanoparticles obtained with pH 11 in 1 microgram solution in 100 milliliters, Section 3 corresponded to nanoparticles obtained with pH 12 in 1 mg solution in 100 milliliters, and Section 4 corresponded to nanoparticles obtained with pH 12 in 1 microgram solution in 100 milliliters.
The project was not carried out successfully because the reagents were in poor condition, as they had excess moisture except for silver nitrate, so it is known that, when weighing each reagent, a considerable fraction of the weight was water. Consequently, the stoichiometric reaction was not performed, the silver nitrate remains in its ionic form dissolved in the solution, and no changes are observed in the UV-vis spectrum in the 400 to 450 nanometers range characteristic of nanoparticle formation.
As for the antimicrobial tests, we found that the solution of 1 microgram in 100 milliliters does not present inhibition of antimicrobial activity. In the rest of the boxes that were divided into 5 fractions, it is demonstrated that sections 1 and 3 of the box are those that present inhibition of bacterial growth. The fraction number 0 that corresponds to the solution of silver nitrate 0.1 molar presented a color change from transparent to yellow with an areola without bacterial growth.
Fin.